right? This is an introduction to coding. Like I was saying, hundreds of years ago, humans actually wanted to create machines that would duplicate the thought processes of humans. But obviously, they were hundreds of years ahead of their time, right? But basically, this is what they wanted. They wanted a machine to be able to do what human beings actually do, the way the human beings think and make decisions. So they were centuries ahead of their time. Eventually, though, they did get it right. And that was actually in the 1900s, right? It was during just before World War II, 1912 or whatever it is. But when you're looking at the human thought process, and if like somebody actually asks any one of you, you know what, calculate 5 plus 2 or 8 plus 3, how exactly do we go about doing that? And if we look at that, right, they had to take the following into consideration. Firstly, as human beings, we have something called short-term memory, right? Now, short-term memory is when we remember something for a short period of time and then we forget it. For example, and I'm sure all of you are aware of this, we learn for the test and a day later we actually forget everything. Then we have the other type of memory, which is long-term memory. Now, when we remember something for a very long period of time, for example, who our parents are, what our address is, what's our name, what grade, what school we go to, things like that. So we have short-term memory, which is for a very short period of time. We have long-term memory. And then obviously, taking those two into account, we actually have the brain processing, where our brain actually does the actual processing, whether it's calculations, for example, 3 plus 5 is 8, or making decisions. Uh, if it is cold, I'll wear a coat. If I'm hungry, I will eat, that kind of thing. So if you look at it, right, these are some of the things, the concepts they actually had to take and incorporate into a machine so that that machine will be able to do what we as human beings actually do. So for processing to actually take place, though, as human beings, we actually need to get data. We can only make decisions based on what we get. Now, as human beings, we have a few ways of actually getting data. And these are some of the ways. Firstly, it's by sight. We see something, we make a decision, we see something, we make a deduction, then we hear things. By hearing, we can, if it's, we can hear water outside, it is raining, we make decisions based on sight, on hearing, on touch, on taste, and on smell. These are our 5 senses, and these are actually our actual input devices. This is how, as human beings, we get data, and based on all of these senses, we make decisions. And all of this falls under input. So anything coming into our brain is called input. Right. Also realize once you're successfully in the brain, the processed data, which is information. Now remember, data are raw facts, right? Data are raw facts. When you process the data, it becomes information. Now your information must be presented. With humans, processed data or information is presented in some of the following ways. Once we actually assimilate the data and make decisions and do calculations, we can speak it aloud, or we can write it out, or we can actually take action, which is actually physical movement. Like, for example, if it is cold, I will take a jacket and a coat and I'll put it on, and this falls under output. So let's look at some of the traits that were actually human traits that were incorporated into a computer system. In humans, we have short-term memory. In a computer system, it's called primary storage, which is RAM, which is temporary. In humans, we have long-term memory. In computers, we have secondary storage, which is your hard disk drive or flash drives, where you're storing it for a long period of time. With human beings, we have brain processing. With a computer, we actually use a central processing unit, a CPU, to actually do our calculations, make our decisions, etc. With humans, with regards to input, like I said earlier, sight, hearing, touch, taste, smell. With computers, we have input devices, For example, how are we going to give data into the put data into the computer, which is basically your keyboard, your mouse, touchpad, microphone, etc. And obviously with humans, when we are giving feedback, it's coming back out, our output, we speak it, we write it, we take physical action. With computers, we have output devices where we can either see our results on the screen, we can get a hard copy on a printer, we can listen to it in a speaker like you're listening right now, right? And you are seeing it, or force feedback, for example, your Xbox and your PS5 and things like that there, right? Now remember, this is just a basic outline of computer concept. Later on, in grade 8, in grade 9, in grade 10, you will actually learn how each of these things actually work, right? Now, it must be noted, you must understand this over here, that computers are basically dumb machines. Most computers are dumb machines. They cannot do anything on their own. You have to tell them what to do. They're like servants. They don't think for themselves. They only do what you tell them to do. So if a computer makes a mistake, the fault is yours. It's not the computer's, because the computer only did what you actually asked it to do. So just remember that. So when we are giving instructions to a machine or to a computer, we have to be very, very specific with regards to what we want it to do and how we wanted to do it, right? Which brings us to an extremely, extremely interesting scenario. And this is something that I've been talking about with learners for years. Right now, imagine you are an employer, you are a boss. You have an employee, you have a worker working for you that does not speak your language. Now, remember, you employed this person. This person obviously works very well, but this person does not speak your language. You need to give your employee instructions, but she or he does not understand. So, how would you solve this problem? And the answer is very simple, that if I want to communicate with somebody that doesn't speak my language, then I am supposed to learn their language. So, understand that with computers, right, we need to learn how to speak to computers. But there are things that you need to understand, that when you are learning a new language, and this is what we're actually starting with today, when we are learning a new language, there are rules which must be followed. And you know, you've learned other languages. Like, for example, when to use a full stop, when to use verbs, when to use nouns, when to use adverbs. So remember, when we are giving instructions to anybody, we have to actually use the proper language. When we are writing something, we actually have to use the proper words. We have to use the proper punctuation. It's the exact same way with coding, that there are rules that you need to learn. So just basically understand this. What you're basically going to be doing now is you're going to be learning a different language. So remember, you want to communicate with the computer. The computer does not want to communicate with you, right? Sorry. Number three, you have to learn a language that the computer understands so you can effectively give instructions to the computer, and you can make the computer work and help you with your work. Now, previously you have learned English, Afrikaans, isiZulu, you could have learned French and German, lots of different languages. But remember one thing, these languages are actually used to communicate with humans. Now, from grade 8 going upwards, we are going to learn a new language which will allow us to communicate with computers. And that language is called Python. Well, in South Africa, we call it Python. Overseas, they call it Python. Whichever way you want to actually pronounce it, it's not important. So remember, we've learned languages before where we to communicate with different human beings from different cultures. Now we want to learn a language that will allow us to communicate with a computer. And remember, Python is a programming language. That means we use it to give instructions to a computer. Python is not the only language. You get lots of different languages. You get Visual Basic, you get Delphi, you get Java, you get JavaScript, you get .NET, you get lots of different programming languages. But since we're going to be dealing with robotics, Python is one of the better programs or programming language to actually use with regards to controlling robots and giving instructions to robots. So our next step is actually, to go and get Python. So we can play around with it and we can learn how to use it effectively. And we're actually going to get started with that just now. And this is how we're going to do it. Guys, while that is installing, all right, and while that basically is going to install, it takes a bit of time. I'm just going to finish up with this here, right? We've just got one more to do. And basically, in order for a computer to actually solve problems, a computer actually requires, firstly, input. Now, these are extremely important concepts. You're going to learn this in actually every grade, right up until matric if you're going to be doing programming, but for up until grade 10 with regards to robotics, this is extremely important. The first important concept is input. Now, with regards to input, you need to get data, right? Now, remember, when we are giving a computer data, it is stored in primary memory. Some of the things that you need to understand is this here. Remember, primary memory is short-term memory. It's called RAM, and it's temporary. So you need to understand that firstly, we need to give the computer input. Secondly, the computer is going to take that input and it's going to process it. It'll do calculations or make decisions or whatever it is. And this is done in the central processing unit, the CPU. Now, once we've given it input, once it's processed it, it's going to give us output. It's going to give us feedback. It's going to present the results. It'll either show it on the screen or it'll play it on the speaker, wherever it is. This is the most important thing. In steps 1, in steps 2, and in steps 3, all of the processing, everything that's taking place, the data that is being processed, the information that is being processed, and all of that there, it exists in primary memory. It exists in RAM, and RAM is temporary. Now, what do I mean when I say temporary? That means if we have data stored in RAM and we shut the computer down, we put the computer back on, and it's gone because RAM is volatile. RAM can only store data as long as the computer has power. As soon as it loses all power, RAM loses everything. Now, if we needed to actually store this data or information on a much more permanent basis, that means maybe 3 months down the line, we want to go back and look at it, then we need to actually take those results and store it in secondary memory. Store it on a hard drive, store it on a flash drive, or whatever it is. Okay? So I hope that helped you guys so far. Now, coming back to that, it's still installing, right? Eventually, okay, guys. Now, we've looked at the human thought process. We looked at how we could actually be using machines. We looked at all of those things there. Let's go and look at some sample programs with regards to Python. And one of the first things that you're actually going to be dealing with regards to Python is this, that it is basically, sorry, it's basically, you can use it as a calculator. So we're going to be looking at some very, very simple things, very, very simple things. And then obviously you are going to be looking at, the first thing that you need to understand is that we can use it as a calculator, and that actually deals with mathematics and what exactly we're dealing with. Now, basically, this here is your console, and this here is your command line. This is where you'll actually type in the instructions, right, one by one, because this is just getting started and just learning, how to actually use the shell, the console, and things like that. So let's go look at something very, very simple. We're going to look at 2 plus 3. And obviously, if I asked anyone of you, what's 2 plus 3, you'll tell me it's 5. So there you have your addition. Then I could go with 5 minus 9. And obviously, it's going to give me -4. Now, remember, for addition, we have plus. For subtraction, we have minus. But there's no multiplication symbol actually on your keyboard. So with regards to coding, we actually can't use that. We actually use an asterisk. So if I go 4 asterisk 9, 4 times 9, and press enter, and that would give me 36. And then obviously we have division. Now, division is quite interesting because you get 2 types of division. Now, remember, we have number systems, and from grade 8, from grade 7, you've been learning number systems in mathematics in school, whole numbers, natural numbers, integers, real, and things like that. Okay. So if we can look at one specific type of division, if I can say 6, and the symbol for division is slash, 6/2, notice it gives me 3.0. 3.0. That means that is a real number. It's giving me, it's a decimal number. It gives me a decimal because, for example, if I went and said 6 divided by 4, it should give me 1.5. Now, if you look at something like that over there, pretty straightforward. But if you look at the the answer over here, the 3.0, right? If you look at the 3.0, what if I just wanted the 3? So let's go and look at the 6 divided by 2, and we'll do it a little bit differently. And this is called integer division with a double slash, or double slash division. And that should just give me the 3. Now, what exactly does the slash slash do? You see, people, what it does is, if I told you 7/3, 2 point, and it's 3 recurring, dot 0.333333. What if I just wanted the 2? That's it. I'll go double double 3, and it would just give me the 2. So you'll notice that for addition, it's plus, for subtraction, it's minus, for multiplication, it's asterisk, for division, it's a slash, for integer division, if we just want the integer part of the answer, right? Because if you look at this here, if you look at this line over here, we've got an integer part, which is the 3, and we've got a decimal part. If you look at this here, excuse me, we've got an integer part, which is the 2, and we've got a decimal part, which is the 3's continuing, recurring, right? So with the double double, right, with the slash slash, we actually just get the integer part. Now, some of you might be wondering, wait a minute, what if I actually wanted to raise one number to the power another number? For example, what if I wanted to, sorry, raise, say, 3 to the power 2? 3 to the power 2, 3 squared, it's 9. It's pretty straightforward. There are other things that you can actually do with this over here, right? There are lots of other, there's a different way of actually doing this. But this is the simplest way. Asterisk, asterisk 2. Now, let's look at that there. We've got 3 asterisk, asterisk 2. It's not 3 times 2. It's 3 to the power 2. 3 to the power 2, or 3 squared, and that should give me 9. So if I said, say, for example, 35 asterisk, asterisk 2, I'm sure you guys can work that out either on your phones or whatever it is. That's 35 squared, and that should be 1225. Yeah. Okay. Now, when we are looking at these mathematical operations, remember there is a particular order. There is a particular order with regards to this mathematical operation. Now, remember, in primary school, we learned the BODMAS rule: brackets first, then off, then division, then multiplication, then addition, etc. So let's just look at a summary of what this happens over here and study that for a moment. Right now, we're looking at our mathematical operations in Python, and it's pretty straightforward. We've got the heading operation, what symbol, a description of what it does, an example, and what the answer should be. So it's pretty straightforward. There's one thing that I did not do up there, but let's go through this. So firstly, multiplication, guys, multiplies two numbers. Example, 2 times 4, which is 8. Division, and remember that he's going to give you a real answer with a decimal point. And you've got 8/3, right? And basically it's going to divide two numbers and give you a decimal answer. And it's going to give you 2.666 recurring. And then we've got integer division, which is slash slash. You're basically dividing two numbers, and remember, it will return only the integer part of the answer. So if you look at that there, if you look at this here, we've got 8/3, it's 2.66666. 8/3 is just giving us the 2, just the integer part. And we've got addition. Well, obviously, that's pretty straightforward. 8 plus 3 is 11. Subtraction, that's pretty straightforward as well. This is interesting. And people, okay, let's go look at the power. The power is basically pretty straightforward. Double asterisk and 3 to the power 4. That basically means 3 multiplied by itself 4 times. And that would actually take you to 81. Now, modulus. Modulus is a very interesting, and it's an extremely useful function, mathematical function to actually use. It's represented by a percentage sign, and basically it divides two numbers and it returns the remainder. So let's look at this over here. Let's look at this example. Now we read this as 6 modulus 4. We read it as 6 modulus 4. So let's look at that example. 6, basically, it basically is saying this here. You know what? What is 6 divided by 4? So 4 can go into 6 how many times? One time. What's left? If 4 can go there one time, what's left? 2 is left. So if we come here and look at an example, if I told you 12 modulus 5, right? Let's look at that. 5, it's basically 12 divided by 5, and please just tell me what's left over. The whole number part, the integer part that's left over. So you've got 12 divided by 5. 5 can go into 12 how many times? 2 times. Okay, what's 5 times 2? 10. So what's left over? If I take out 10 from 12, I'm left with 2. Get it? So if I went with 12 modulus 8, how many 8s are there in 12? There's 1 8. If I take away that 1 8 from there, what's left of 12? And that should be 4. So if you go back and look at this over here, modulus is extremely useful, because modulus can basically tell us whether one number is divisible by another number. Now, how do we determine whether one number is divisible by another number? Think about it now. Here we go. Here, 6 divided by 2. Can 6 be divided by 2? Is 6 divisible by 2? If you look at it, we'd get a 3, right? 6 divided by 2 is 3, and we've got a 0 decimal. That means 2 can go into 6 3 times, and there's 0 remainder. So if you want to determine whether the first number is divisible by the second number, you use modulus, and you actually check. Now, if modulus gives me 0, that means yes, the first number is divisible by the second number. Perfect example, if I said 24 modulus 6, 6 can go into 24. 6 can go into 24 4 times. Your remainder is 0, because we can go back and look at 24, and that's 4. 24 divided by 6 is 4. 24 modulus 6 is 0. So looking at the summary, right, you need to know this over here. Now, like I said, in addition to this summary, right, in addition to the summary, we actually have your BODMAS rule. Now, obviously, the B is for brackets, right? Your O is for off. And by the way, what is your mathematical operation for off? Off, if I told you what is half of 8, half of 8, half of 8, half of 8 is actually 4. So let's come here and look at it. 0.5 is half times 8, and your answer is 4. Well, it's giving me an error there because I made a mistake myself, right? Sorry about that. Zero point. Oh, okay. Let me just close this for now. Open it again. So while that is happening, off is multiplication. And then obviously your division and your multiplication, right? Your brackets first, then your off, which is multiplication. Division multiplication can be done at the same time, and then you have A for addition, and finally you have S for subtraction. So you need to remember these things, your BODMAS rule, and you need to look at that thing. Now, if we're looking at this over here, right, like I was saying, 0.5 half of 8 should give me 4, right? So your off is multiplication. Now, if we're looking at something like this over here, how would this actually work? So if I went and looked at, we're looking at BODMAS rule now, 3 plus 2 times 5. How does that work? Which would it work first? Now we've got addition and we've got multiplication. Obviously, it's going to be working on multiplication first. So you're going to get 3 plus 2 times 5. 2 times 5 is 10. 10 plus 3 is 13. But if I had this, 3 plus 2 times 5. Now, how would that work? Which would it work out first? Remember BODMAS rule, it's going to work out your brackets first. So 3 plus 2 is 5. So this here is going to be 5. And 5 times 5 is 25. Right? So it's not that extremely difficult, but you guys should actually make a note of this over here. Once you've downloaded some of these examples, once you've downloaded the actual example, you can go try your own examples. Remember, you can actually put formulae in to work out that. For example, if you went to the supermarket and that is 15%, you went to the supermarket and you bought something for 125 rands, and you need to know how much VAT you're supposed to pay for that. So that is basically 15, and 15% is 15 times over 100 times 120, 125, and it should tell you 1875. Now let's look at it, right? The VAT is going to be 18 Rand 75. So how would I actually work this out with the amount? How much did I purchase for 125? Plus, in brackets, I go put 15 divided by 100 times 125. So what is this basically going to do, guys? Remember, this here is going to give me 18 Rand 75. And it's going to add the 1875 to that, which should give me 138, 145.75. I hope. Or 143.75. I can't add. Anyway, but you get the idea. So remember, in grade 8, in grade 7, you did percentages. You did in mathematics, you did percentages. You did probability. You did dividing ratios and proportions. You can use Python to actually do all of these calculations. But so far, remember, all we did was just touch the tip of the iceberg, because if you literally look at it, right? If you really look at it, we got lots and lots of other stuff to do. In fact, the lesson after this for grade 9 and 10, and it's going to be from now right until the 22nd, except for the weekends. And I hope all of you are actually going to be, logging in and paying attention and going home. I mean, you're already at home, downloading Python and trying things out on your own. You know what I mean? Because it's exciting, it's fun. And I'll tell you something, that when when I was in grade 10 and I did computers for the first time, the first program I wrote was to add two numbers, that got over the moon. Because I mean, I actually told the computer to do something and it did it correctly. So it's fun, but you're not going to be doing something as simple as that. You're going to be doing lots and lots of exciting stuff. And obviously, like I said, it's moving on into robotics. So understanding this language is extremely, extremely vital, because at the end of the day, this is going to help you advance with the coding and with the programming and all of that. So if you look at this over here, we can actually take all of our stuff and we can put it in over here and we can work with it. So far today, if we're going to be looking at what we've done today and what we've covered, right? Remember, we've covered input, where we are giving the data to the computer. We've covered output, where we're getting results from the computer. And we are looking at processing, where the computer actually works and gives us, does the calculation, and then obviously we're getting output back. So you need to understand all of these concepts for obviously the next lesson. And if you look at what we're going to be doing now, and this is important because if you look at this over here, we've got file, we've got edit, obviously file. There's lots of stuff over there, right? And obviously we're going to be covering that, what each of those things actually does. And we've got edit. Now, obviously, edit is like an editor where we can find something and we can replace it and we can go to a particular line. And then obviously we've got the shell, which is I'm about to show you just now, right? And we've got here, go to file, go to line, stack viewer, options, and all of that there. Let me show you something interesting though. I just want to show you something extremely interesting because I was fascinated the first time, right? I was actually fascinated the first time. If you look at, let me just close this again, just to go and open it, right? Once you download Python and you actually open it, you should actually go and look at this over here. If you look at it's called under help, the turtle demo, and this was fun. This was, yeah, a lot of fun. Let's look at the examples. What was it? Where was this? Here, yin yang. All of you should know this, right? Yin yang, right? You'll know the black and white and things like that. Now, if you look at the code over here, this code, it looks very, very confusing. That they do not worry. By the end of these 3 weeks, you would understand how to do quite a bit of stuff. By the way, that's basically a function of that thing. But this is the fun stuff. If you actually go and, just look at this over here, because this gives you an idea of what you can do. Check it out. Strangely enough, guys, they're actually using something over here called a turtle. And in the 1980s, there was a program called Logo that used a turtle to actually do this. So this is just an example of what you can do. Look at the clock. And by the way, that's the time now. That's actually giving you the real time, right? And there's obviously your code over here. So please don't get scared by that code and things like that over there. It's not that complicated. Now, coming back to this here, if you look at the top of here, we've got file, we've got edit, we've got shell. Now, remember, we did all of this in this program. Now, I want to get rid of this over here. And normally you would say, just going to highlight this and delete it. No, you can't do that. So let's look at how we are going to open up a new program. And trust me, even I didn't know how to do this. So I'm basically going to go over here and I'm going to go to save as, right? Save as, right? So I'm going to go to PC. And now I'm just going to save it as EX1, right? Now you'll notice if you look at this over here, these are some of the other things that I was messing around with. The file extension is .py, obviously .python, right? Now I want you to look at this over here. I've got EX1 and I'm going to save it, right? So I'm going to come here, back over here. Now, if I want to open up a new, I'm going to close Python. I'm going to open up, go back to my folder, and I'm going to double click on. Oh, sorry. I'm going to right click, edit with IDLE. It's your IDLE Python, right? And it's not get up over there, right? But you'll notice that it actually opened up your program that you've actually worked with. Okay. Now, since we still have a bit of time, right? Let's go and look at something. Well, actually introduce something that I was going to do with you tomorrow, but it is important. So you need to understand this as well. Now, remember, what did I say? I told you that all of the data that we give into the computer goes into primary memory, into RAM. So understand one thing, when I actually put this in over here, all right, when I actually put that in over there, just give me a moment. I'm just going to close this and open that again. When I actually put in all of those values, right, when I put in all of these values here, right, for example, if I said 2 plus 3, the 2 went into RAM, the 3 went into the RAM. The plus was basically telling the CPU, hey, you know what, take these two numbers, add it, right, and then display it. So if you look at the input and the processing and the output, what was my input? What did I give the processor? What did I give the CPU? I gave it 2 and I gave it 3. My instruction to the processor was add. The processor added the two numbers and it displayed the answer. Now here's the thing. 2 went into RAM, into primary memory. 3 went into primary memory. 2 plus 3, 5. 5 is still in primary memory and then it was displayed, right? Now, sometimes we want the user to actually enter data. We want the user to actually enter data, where we will get to that tomorrow, so forth. But how do we actually reference a variable? Now, let's look at this over here. What is a variable? Sorry. A variable is basically a letter of the alphabet. Let's just come here, right? A variable can be a letter of the alphabet, X. It can be a word. It could be dog. It could be uh, two words. But obviously, these are variables. That means, what does a variable mean? The word variable comes from the word vary. Vary means to change. Vary means to be different. It can be different values at different times, and I'll show you what I'm talking about just now. Right? Let's look at this here. Let's assume I'm using the variable x. Now, what does x mean? I want to put a value into this variable. I want to put a number. I want to put an integer. I want to put an age into this variable x. How do I put data into a variable? Important, guys. Very, very important. You need to remember this. The word is assign. How do we put data? When we're putting data into a variable, we are assigning that data to that variable. Now, what is the assignment symbol? The assignment symbol is equal to, and if I said 16, okay, x equals 16, that's how we would normally read it, but technically speaking, it reads as x is assigned 16. Now, what does that mean? It means that 16 is going into x. If I come here, and if I go, that's how it would read. 16 is going into x. It goes from right to left. It goes from right to left, right? So if you look at this here now, x equals 16. X is assigned 16. When I press enter, nothing happens because I took the 16 and I put it into x. If I want to show the data stored in a variable, now remember, what did I do first? A variable. And that variable, I've called it x. I've given it a name. 16, now this is important. 16 is in RAM. 16 is in primary memory. I'm taking 16 and I'm putting it into x. So right now, when I talk about x, I'm talking about the value 16. So if I come here, and how do we show the data stored in a variable? How do we show the user? How do we see what's in that variable? X, we use the statement over here, print. It's called a print command. Important, guys. A print command. So that'll be print x. Now, let's explore this here. Whatever is stored in x, now this is important. Whatever is stored in x, it's going to display. I could have done this. Now you'd say, hey, it's the same thing. Now you'll notice the X changed color. The X is within single quotes. If I say print X like that there, guys, it's going to print X. Whatever is within the single quote, it will print. For example, if I said print it will print whatever is within the quotes. Coming back to this X over here, if I want to display whatever is stored inside the X, right? Let's come back here and do this again. Right? If I want to store what's inside the X, if I want to display, sorry, what's inside the X, I would do that with no quotes. So print X. So whatever is inside the X, we're going to be displaying that. And if I press that, and it becomes 16. So remember, at the moment, when I refer to X, I'm referring to 16. I can change it. I can come here and say X is assigned 89. And then come here and say print X. So remember, what was X? X was 16. I took 89 and I put it into X. What happened to the 16? The 16 disappeared. The 16 gets overwritten. The 16 is lost. It's called garbage disposal, people. I'm being serious. It's called garbage disposal. So if I do that there, and can you see that? So X is 89 now. So remember, one variable can store one value at one time. One variable can store one value at one time. One variable can store more than one value, but we will look at that obviously in grade 9 and 10. So looking at this over here, if you look at X is assigned 89, right? I could come over here and I said Y is assigned, and in single quotes, oh, sorry, programming syntax. So Y is assigned Ria Mirage. So basically, what does that mean? What's going to be stored in Y? The name Ria Mirage. So if I come here and go and print Y, what should it display for me?
Ria Mirage.
Very, very good, madam. Right? It should display Ria Mirage. Do you get the idea? So remember, one variable can store one value at one time, at the moment,
So
right?
let's say
So
S is equal to implement it, then I would say print, put it in brackets O. No S, then it implement.
say that again. Okay. So we looked at a variable. A variable can store one value at one time. We looked at a print. How do we display the value in a variable? Using a print statement, right? Now, obviously, I'm hoping somebody can actually tell me what this is going to be doing. If I said A is assigned 9, and if I said B is assigned 90, okay, let's make it 70. And if I come here and say C is assigned A plus B, so three variables. A is assigned 9, so that means A will take on the value of 9. It actually is not actually taking on the value, but we'll discuss that in the future. A is assigned 9, B is assigned 70, and C is assigned A plus B. So, guys, you try to figure this out now. If I say print C, what is it going to be printing for me? If I say print C, what is it going to be printing for me? I want you to look
79.
very, very good. Oh, 79. How does that work? Remember, I told you it goes from right to left, from right to left. So if you look at this, what is the value of A? 9. What is the value of B? 70. It actually the processor will substitute those two numbers over there, add it up, and take that answer and store it in C, right? So what have we looked at? We've looked at a variable. A variable can store a number. A variable can store a name. A variable can store basically almost anything, right? We've looked at where instead of using actual numbers, we can actually use variables. We've looked at changing values, right? Here we go though. If I said y is assigned 60, and if I come here and say y is assigned y plus 90, and then if I come here and say print y, oh, sorry, can't see that. I'm hoping somebody can tell me what is happening. Okay, over here, y is taking on the value of 60. Very good. Well, we can all follow that. I'd like to know what's going to be output over here. Remember, assignment takes place from right to left. That means if there's any calculation to be done, it'll take place on the right. And once it gets one final answer, it'll take it and store it on the left. Okay? Okay, well, time's almost up. So let's see what happens just before we go, even if it's a minute or two over. Y is assigned 60. It's going to come over here. What is Y? 60. 60 plus 90 is 150. And 150 is going to go into Y and it's going to overwrite the 60. So 150 should be output. Okay. So just remember, guys, this is important, right? Just remember that you need to download Python. You need to install it on your machine. Now, remember, you might have a 32-bit machine. You might have a 64-bit machine. You might go and download the 32-bit, right? Remember, I told you, you go to Windows, Google, Python 3.9.1 for Windows. Go and look for the Windows executable. Go and look for the executable and install that. Okay. If the 32-bit doesn't work, then go and download the 64-bit. You'll find it. And if you don't find it under your start or whatever it is, okay, go under search and search for Python, right? Or IDLE, in fact. Guys, see here? And search for idle, 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 right? And that should actually help you. I'm hoping by tomorrow, most of you would have tried this stuff out. All right. So thank you all for attending, and hopefully we'll all be together tomorrow.
So what time do we meet tomorrow?
At 2.